we end up in this section 10.5, this is what we need to do is rationalize the denominator. In the sense, it's like a division. It's just that we don't divide rational expression. We don't need to divide rational expression. The one thing that we want to do, is we want to rationalize it. And the rationalization is basically tell you that whatever your expression is, we just don't want the denominator to contain a radical. That's our goal here is whenever they ask you to rationalize the denominator, is basically tell you that whatever your denominator, your numerator can be whatever they want to be, but the denominator here, we don't want a radical symbolic under this denominator. Okay, so your goal is how can we get rid of this radical on the denominator? Okay, so that's the objective here in 10.5 is dividing, but in the sense it's rationalization or rationalize the denominator. So if we were to have this problem, and if we do have this problem here, how can we get rid of the radical? Remember or recall that in order to get rid of the radical, we need two of the same, right? We need two of the same item inside the radical. Because if you take a square root of a times a square root of a, you will get square root of a square. And remember, the square and the square root will cancel each other out, or in the sense that the square root of something times a square root of the same thing, it's just that item on the outside, right? We did this yesterday. I mentioned that a square root of a square root of 11 times a square root of 11. In this case right here, the square root of 11 times a square root of 11 is basically 11 on the outside, right? This item that we mentioned right here, the square root of the same thing times a square root of the same thing, square root of 11 times square root of 11 is just basically simplified to be 11 on the outside because we have a pair of two number, right? A square root of 5 times square root of 5 will give you 5 on the outside, right? So that's the idea, or that's what we have. So if we were to have this problem here, and again, same thing go here, a square root of 3 times square root of 3 will give you 3 on the outside, square root of 7 times square root of 7 to give you 7 on the outside. And this is what we have is 3 minus 7, right? Square root of 11 times square root of 11, and again, same item we have. But let's take a look at this thing here. So our objective in 11.5 is how do we get rid of this square root? To be in short, if you just have a square root, to be in short, just like before, all we need to do is take a square root of 13 times square root of 13, because we mentioned this, a square root of the same item times a square root of the same item, you will have that item on the outside. But to be fair, if we multiply the denominator by square root of 13, we have to multiply the numerator by square root of 13. So basically, in short, this is what you guys do is whatever the denominator is, all you need to do is take this denominator and basically take your expression and times the denominator over itself. Because what is the square root of 13 over square root of 13, ladies and gentlemen? What is something over itself? Well, anything over itself, do you see that it's equal to one whole number? So yes, we changed the look of the problem, but we haven't changed the problem itself. Because if you multiply this thing here, once you have this, we just do everything the same, which is 3 times square root of 13, which is 3 times square root of 13 will be 3 times square root of 13. Square root of 13 times square root of 13 will be, again, square root of 13 times 13 on the inside. That's our rule. If we have two radical, we can merge them into one. And if you see that a square root of 13 and square root of and 13 on the inside is basically 13 on the outside. One thing, ladies and gentlemen, one thing is do not do this. Do not say, Mr. Tran, this 13 and this 13, they cancel out. They are not. They are not canceled out because one of them is inside the radical and one of them is outside. Remember, the radical, a square root of 16 over 16 are not the same, because a square root of 16 is equal to 4, but 16 is just 16 as a whole number. So again, don't cancel them out if one of them is in the radical and the other one is not. Okay, but this is all that you need to do, ladies and gentlemen. This is all that you need to do. If you look at this item here, if we have one radical, the rule tells us that we can split them into two radical, right? And if we split into radical, this is the goal, or the objective is we don't want the denominator to have a radical symbolic. Whatever this thing is, I don't want it to contain a radical. And to not make this thing contain a radical, if we have only a single radical, all we need to do is just multiply that radical over itself. So to rationalize, all we need to do, multiply whatever my denominator, I should say, over itself, which is a square root of 11x times square root of 11x. Why? Because a square root of 11x times square root of 11x will give you 11x on the outside. And how do I multiply on the inside? Up here, square root of 5 times square root of 5 to give me square root of 55, because 5 times 11. Again, not disregard, but distinguish the difference between this item, square root of 5 times square root of 11, versus this item, 3 times square root, right? Again, we do not take the 3 times the 13 on this side because one of them is a whole number, the other one is a radical, right? Inside the radical. Over on this side over here in my yellow box, when I have this yellow box, right? In my yellow box, both of them is inside your radical. And if both of them are inside the radical, that's when you multiply, okay? So looking at this thing here, let me ask you guys question how to rationalize this denominator. Same idea go. Let's take a look at this item, right? Take a look at, let's see. And if this were to be your problem, then hopefully you guys say, oh, this is easy enough. If I have just a radical of 12y, if I have just a radical of 12y, well, all I need to do is take the square root of 12y times a square root of 12y, right? And this is what we have. And if I multiply square root of 12y on the bottom, I need to multiply square root of 12y on the top, right? So previously we have a square root of 11x. We have a square root of a square root of 13, right? Now we have a square root of 12y. And if we have just a single square root, then this is all we need to do is just multiply the same thing over itself. And if we multiply the same thing over itself, that is 1. We change the look, but we not change the problem itself. So this is what we have is 5 times square root of 12y will give me 5 square root of 12y. And 12 times 12 will give me 144. Y times y is y squared. Square root of 144 is 12. Y squared will give me y. So everybody see that we all met our condition, right? We don't want to see a radical on the denominator. We did it. There's no radical on the denominator. But the problem, so looking at this thing here, we get rid of that, right? We have our purpose have met. Before we say that this is our answer, before we say that, Mr. Tran, this is my answer, what happened? If you type this in your MyMathLab, they will tell you, although your answer is correct, it's not in the lowest term. And you say, wait a minute, previously the two problems we did, there's nothing going on, but what is this thing here? Why there's not in the lowest term? Well, the problem is, ladies and gentlemen, do you recognize the 12, the radical 12, square root of 12? There is a perfect square in it. There is a perfect square in a 12, which is 4 times 3. And 4 times 3, why, or what do I mean by perfect square? Well, 4 is a perfect square because a square root of 4 is equal to 2, meaning I can bring the 2 on the outside. And just like before, whatever I bring to the outside, I need to multiply to the outside number. So 2 times 5. 2 times 5 to give me 10. And you say, wait a minute, Mr. Tran, earlier you told me that we cannot simplify, we cannot cancel. Yes, we cannot cancel this 12. We cannot cancel this 12 with this 12. We cannot, right? Because one of them is in the radical, the other one is not. What did I cancel here? Well, do you see that I have a common divider between a 2 and a 12? 2 can go into 1 time. So instead of say this, right? Instead of say 10 over 12, and again, 10 over 12, as you can see, 10 over 12 is the same as 10 divided by 12. 10 divided by 2, which is 10 divided by 2 will give me 5, and 12 divided by 2 to give me 6. So basically, you can see that 10 over 12, I can reduce it to 5 over 6. And that's what I did here. The only thing I did was I reduced this item here. I say 2 going to 2 1 time, and 2 going to 12 6 times. And that's why my answer here, not this answer, right? My answer is not 5 square root of 12, but my answer is 5 square root of 3 all over 6y. Again, the only reason, like I mentioned, if you type this as your answer, if you type this as your answer, the item tell you, although your answer is correct, but it's not in the lowest tone. Okay, so the idea here is the same. Whatever we learn, we still kept it. Whatever the rule that we have to maintain that rule. So as long as there's a perfect hidden perfect square, we need to in a sense, we need to extract it out. Okay. So question with this item here, ladies and gentlemen. Question with this item that we have here. Well, if you don't have question, let's take a look at this thing here. Let me ask you, let's go back. Let's try another one, right? And let me do it, do it by hand. And then we connect back to this item here. So if you were to, for instance, let's try this item. One second. Okay. So let's say if I have this problem and I ask you, let's say D, and rationalize, let's say 2 over a square root of 18. So if you see this, ladies and gentlemen, again, let me make it a little bit nicer. So a square root of 18. So I want to point this thing out to you guys. And again, this is what you guys did, right? You guys say, well, we have a square root of 18 on the denominator. We don't want a square root of 18 on the denominator. So what do you do? Well, all we need to do is to get rid of a square root of 18. We just need to multiply a square root of 18. Agree? And yes, you are technically perfectly correct. You are multiplied by a square root of 18. And if you multiply a square root of 18, everybody see that a square root of 18 times a square root of 18 will give me basically 18 on the outside. And that's our goal, right? Our goal is the denominator no longer have a radical, no longer have a square root. And if we were to multiply on the denominator, we need to do the same thing on the numerator, which is a square root of 18 here. So therefore 2 times square root of 18 is basically 2 square root of 18, right? And that's what rationalize the denominator tell you to do. Whatever the denominator, if we have just a single radical, to get rid of the single radical, all we need to do is multiply to make it easy, multiply to that radical on the numerator and multiply to that radical on the denominator. Okay, and if you were to give me this answer, on the MyMathLab, they will tell you, although your answer is correct, is not in the lowest term. And then you say, oh, Mr. Trent, I saw it. I saw it right here. I saw this 2 and this 18, because 2 and 18, they have a common divider, right? Because 2 is a whole number, it's on the outside. I can take the 2, go into 2, will give me 1 time, right? 2 divided by 2, that will give me 1 whole number. And I can say 18 divided by 2, that would give, excuse me, right? 18 divided by 2, that will give me 9. So everybody see that I can reduce this item. I can reduce this item. I don't need to put a 1 because, again, 1 over or 1 in front is the same. 1 over 9, but I don't really need to put a 1. This is what I have. It's square root of 9 over 18, right? And again, do not make this careless mistake and say, the 9 and the 18. Remember, the 9 is a whole number. The 18 is in the radical. This 9 and this 18 cannot be reduced because one of them is in the radical, one of them is in the whole number. And then you say, okay, this is my answer. All right, you say, okay, this is my answer, but not yet, right? Hold on a minute. You say, what else, Mr. Trent? Because if you look at this item right here, ladies and gentlemen, if you take a square root of 18, do you agree that a square root of 18 is the same as 9 times 2? Why 9 times 2? Because 9 is a perfect square. This is a perfect square, ladies and gentlemen. And if it's a perfect square, if it's 9 in the radical, everybody see that I can bring out a 3, right? Because it's a perfect square, I can reduce this and take out a perfect number, which is 3. 3 times 3 is 9, so I take out one of them, 3. And in this case now, as you can see, once again, this is a whole number and this is a whole number. So if this is a whole number, this is a whole number, now we can reduce this item. And again, basically I take 3 divided by 3 to give me 1. 9 divided by 3 to give me 3. So as you can see, your final answer should be square root of 2 over 3. This is what your final answer should look like, not this item here, because the item on the number on top or in blue is reduced. So one thing I want to point out before we go on to the next one, I'll reminder that this is my problem. My problem is 2 over a square root of 18. Now, you say, is there any other way that I can do this problem? Well, there is. And some of you guys say, Mr. Strand, what happened if I reduce it in the beginning? And if you reduce it in the beginning, that's perfectly fine. Do you agree that 18 is the same as 9 times 2, right? The look is different. 18 is a whole big number. 9 times 2 just breakdown of the multiple of 8, right? And why do I break down 9 times 2 and not 3 times 6? Because 3 times 6 is 3 and 6 is not a perfect square, so I don't break down 3 and 6, right? The only thing that 18, like again, 18 times 1, 2 times 9, and 3 times 6. Those are the multiple of 18, right? And none of this thing here have a perfect square, so I don't need to break down a number that doesn't have a perfect square. Break down 9 because I know 9 is a perfect square. And if I break it down, do you see that I can take out this item here? I can take out this item, which is I can take out a 3, right? A perfect square is 9, but inside a radical, I can only take out 3. So now let's focus on to this new problem. This is the new problem I have. the new problem I have is this problem, ladies and gentlemen, and you will see this problem here. You will see some problem like this, 2 over 3 square root of 2. Remember our objective. Our objective is basically tell you, is as long as the denominator, the denominator have a radical, then we need to get rid of that radical. The 3 is not in a radical, so the 3 is fine. We don't care about the 3, we just care about this radical 2, right? So how do we get rid of this radical 2? Well, to get rid of the radical 2, all we need to do is multiply by a radical 2. Because if you look at this thing here, if I multiply this with a 3 radical 2, multiply to a radical 2 and a radical 2, 3 times 2, because again, square root of 2 times square root of 2 is basically 2 on the outside. Because this item here will give 3 square root of 2 times 2, which is 2 times 2 is 4. Square root of 4 is basically square root of 4 is 2 on the outside. And what is on the numerator? Well, on the numerator, if I multiply the bottom by 2, I have to multiply it by square root of 2. And I still have 2 square root of 2. So looking at this problem, this is my new problem, or this is my answer, 2 square root of 2 all over 3 times 2. And again, the 2 and the 2, or if you don't see 2, if you say, well, Mr. Tran, 3 times 2 is, that's fine. If 2 times 3 is 6, do you agree that 6 and 2, they have a common divider? And what is the common divider between 6 and 2? Well, the common divider is 2, and 2 going to, and as you can see, our previous problem is this item here. Square root of 2 over 3. If you do this, you square root of 2 over 3. So again, it's the same concept. The only thing that I mentioned here is if you were to have something like this, you can do the long one. You can do the long way. Let's say we have 7. Let me give you something that you cannot reduce. Let's say we have something like this, 9 square root of 5. Let's say you have this problem. The reason why I mentioned this problem is, ladies and gentlemen, ask yourself, which one have a radical, right? I don't need to multiply the whole thing. I don't need to multiply 9, which you could multiply 9 square root of 5. You can, but you don't need to, because the reason is, if you do this thing here, you make your, ask yourself, what is your purpose? What is your goal? Your purpose, your goal is we want to get rid of the radical. The radical, the only radical is a radical 5. So all you need to do is multiply the radical 5 rather than 9 square root of 5. And if you multiply the radical 5 on the bottom, you need to multiply a radical 5 on top. And if you multiply radical 5 on top, this is what you have is 7. 7 times square root of 5 is 7 times square root of 5. And a square root of 5, everybody see that a square root of 5 times a square of 5 is equal to the root of 25, and a square root of 25 is basically 5 on the outside. Or in the sense that this is what you have is you have 9 times, and 9 times 7, 9 times 5 will give you 45. And that is your answer. Rather than multiply the whole thing, okay? So as long as they have a radical, all you need to do is multiply the radical if it's multiplication. So with this particular problem here, ladies and gentlemen. Now let's go back to this this item that we have last time. Let's say if I ask you to multiply, and let's say if I ask you a square root of, let's do square root of 11. I cannot use 11 because it's prime. Let's say square root of 11 plus 3 times square root of 11 minus 3. Okay. Let's practice this thing here. How do we multiply this item? How do we multiply this item? This is what we have yesterday. And to multiply this item here, reminder that this is what we need to do is we need to take this item and distributive to the first term, take this item and distributive to the second term. So if you distributive into the first term, this is what we have is we have a square root of 11 times square root of 11. And because of this negative, we have a negative square root of 11 times 3, right? And if we second item, we distribute them here, we distributive this item here. So 3 is positive. 3 times square root of 11 will be 3 times square root of 11. And 3 times a negative 3 will give you that item. Because of negative, you still have to cap a negative. So what do we have here, ladies and gentlemen? What is a square root of 11 times a square root of 11? Again, a square root of 11 times square root of 11 will give you a square root of 121, or a square root of 121 is the same as 11 on the outside. And what is 3 times a square root of 11? Well, 3 times a square root of 11 is 3 times square root of 11, because the 3 is a whole number, and square root of 11 is square root of 11. And what is 3 times square root of 11? Well, 3 times a square root of 11 is just 3 times a square root of 11. And on this item here, the last item we have is 3 times 3. 3 times 3 is 9. So I want to show you guys, this is what our goal is. As you can see, do you agree that we have a negative 3 square root of 11 and a positive 3 square root of 11? Do you see that this thing here, they cancel each other out, right? They cancel them out, which is this thing here and this thing here, they cancel. And now this is what we have is 11 minus 9. And what is 11 minus 9? 11 minus 9 is 2, okay? Let's try another one. Let's try another one. And again, I will take question after this one here. Let's say if we have something like this. Let's say another one. Square root of 7. Let's do minus square root of 5 times square root of 7 plus square root of 5. And again, hopefully you guys see, and again, I purposely do this. You guys already saw that, again, everything is the same. The only thing different is the sign. But if you don't see it, it's fine. If you take a look at this thing here, do you agree that the first thing we have, let me use red. The first thing we have is we need to take a square root of 7 and distribute it to that item. So if we take a square root of 7 times square root of 7 plus square root of 7 by item I took and I multiplied to this 2 item here. So I took a square root of 7, I multiplied to this 2 item here. That's where I have my red ink. Let me do my blue ink. And again, the blue ink, I have square root of 5 times this, a negative square root of 5 times that. So a negative square root of 5 times 7 will give me a square root of 5. Square root of 5 times square root of 7. Negative 5 times that. So let's take a look at this thing here, and hopefully you guys see that when you multiply the radical, it's basically, again, 7 times 7, which is 7 times 7 will give me square root of 49, and square root of 49 is equal to 7 on the outside. When you have two of the same multiply in terms of a square root, they will be that item on the outside. And plus a square root of 7 times square root of 5 is basically a square root of 7 times 5, and a square root of 7 times 5 will give me a square root of 35. Minus a square root of 5 times 7, which is a square root of 5 times 7, is minus a square root of 35. And similarly, this thing here, a square root of 25 and a square root of 25 L by C. L by C that we have only 5 on the outside. This is the unique thing about this item here, ladies and gentlemen, is the middle term, they will always cancel out. Square root of 35 minus a square root of 35, that will cancel out. One of them is positive, the other one is negative, they will cancel. And now if they cancel, I still have a 7, I still have minus 5, and what is 7 minus 5? Well, 7 minus 5 will give me 2. Okay. Again, this is what we have is 2. And this is, ladies and gentlemen, this is our purpose. Our purpose is this: to recognize that this item here, one of them is negative, the other one is positive, and everything else is the same. Square root of 7, square root of 5. We 11 positive 3, 11 negative 3, meaning everything the same. The only thing different is one of them positive, the other one is negative. Know that this is a conjugate of each other. And if it's a conjugate of each other, the middle term will always disappear. So the reason why I give you guys this, ladies and gentlemen, so that if you see this problem, let's say we have another example here. If I give you this problem, let's do square root of 13, square root 2 times square root of 13 plus 2. So this is the goal. This is the purpose. This is what I want to point out is, if you look at this problem, do you agree that everything is the same? We have a square root of 13, 2, square root of 13, different the sign. And the only thing different is the sign, which is this is the conjugate. If you see that this is the conjugate of each other, all you need to do is take the first item, times the first item, take the second item, times the second item. You don't need to do the middle term. You don't need to do the other one, because the middle item will eventually cancel out. And if you take square root of times a square root of 13, square 13 times a square root of 13, eventually, hopefully, you will see that it's basically 13 on the outside. And if you take a negative 2 times a positive 2, a negative 2 times a positive 2, and as you can see, what is negative 4 or 13? Take away 4. Well, 13 take away 4. Everybody see that is equal to 13 take away 4 is equal to 9. Right? And that's what we want. You see the question, but this is our goal here, is no matter what I give you, I can give you the radical, 15 plus 9 times radical 15 minus 9. And the only thing different is one of them is positive, the other one is negative. So as you see this, you need to do is take this item, times this item, take this item, times this item. And a square root of 15 times a square 15 eventually will give you 15, because 15 times 15 is 225. Square root 225 is just 15 on the outside. And 9 times a negative 9 will give me a negative 81. So what is 15 minus 81? Well, 15 minus 81 will give me a negative, right? 15 minus 81 will give me a negative 66, a negative 66, 70, 81, right? So that's what we have, okay? Question with this item. And if you remember, well, question here. And if you remember, if you remember, this is what we had earlier, right? If, in chapter 5, we have this thing. One of them is positive x minus 7. The other one is x plus 7. And I told you that instead of FOIL them out, all we need to do is take the first term square, right? Take the first term square, which is x times x is x squared, minus the last term square, which is 7 times 7. And 7 times 7 is 49. So this is what we have earlier, that our problem, the only thing that is different from this one here to this one is this item over here, we have x and 49. We cannot do anything. But the item over here is 15 and 81, because it's a whole number, is a constant, then we can subtract them, okay? So let's take a look at this thing. If you don't have question, let's take a look at why I mentioned this. Why do I mention that, ladies and gentlemen? So the reason why I mentioned that, or take off topic, not really off topic, is because we have this problem here. And this problem is not the same like 3. Everybody see that this thing here, we have a square root of 7 minus 3 is not the same as 3 times square root of 7. Okay, 7 square root 7 minus 3, meaning there is some, if you look at this item, this thing here, we don't have any addition, we don't have any subtraction. But this item over here, we have a subtraction. So if we look at this thing here, we say, well, what is our goal? Mr. Tran, what do I need to do? Well, our goal is we need to rationalize the denominator. Meaning whatever my numerator or denominator is, my goal is I need to get rid of this square root of 7. And to get rid of the square root of 7, ladies and gentlemen, if you have some addition or subtraction, in order to get rid of the square root of this item here, you need to multiply by the conjugate. And what does it mean by the conjugate? The conjugate, like I keep on mentioning to you guys on the previous 3 problem, the conjugate is everything is the same, but the only thing different is the sign. The only thing different here is one of them, if this problem is negative, the conjugate will be positive. If the problem is positive, the conjugate will be negative. And if we were to have this, and again, I break it down, I type this thing out. If we look at the top, this is what we have is 7 times square root of, 5 times square root of 7 plus 3. And 5 times square root of 7 is 5 times square root of 7. 5 times 3 is 15. If we take a look at the bottom, this is what we have. And I purposely went over or off topic to show you that this is what we have, ladies and gentlemen. We have everything the same except the sign. Square root of 7, 3, square root of 7, 3. The only thing is one of them is negative, the other one is positive. So everything is the same except the sign. So if you can see that everything is the same except the sign, now all we need to do is take the first item times the first item, take the last item times the last item. And the square root of 7 times square root of 7, which is square root of 49. Square root of 49 will give you 7. 3 times 3 will give you 9. And what is 7 minus 9? 7 minus 9 is negative 2. So this is what you have is on the bottom, on the denominator, you have a negative 2. Okay, and distinguish the difference between D versus C. Distinguish the difference between D versus C. The one most important thing between D versus C is in D, there is an addition, or in this case, there's a subtraction. In C, there's no addition or subtraction on the denominator. Okay, so let's try another one. I think I have 2 more. Let's take a look at this thing here, which, as you can see, they ask you to rationalize the denominator. So how do we rationalize the denominator? Well, we recognize, if not, hopefully you'd recognize, we don't care about this numerator. Again, we don't care about this item here. It is outside, right? Well, it's in outside, but just for now, don't worry about the numerator. What do we have? We need to worry about the denominator. So how can we get rid of this denominator if there's an addition? If there's an addition, we need to multiply by the conjugate. What is the conjugate? Like I mentioned earlier, if it's the denominator have an addition, the conjugate will be subtraction. Everything the same, with the exception that instead of addition, it's going to be a subtraction. And if I multiply the bottom by the conjugate 4 minus square root of 5, I have to multiply the top by the same number, 4 minus square root of 5. And if you look at this thing here, on the numerator, we have square root of 7 times 4 minus square root of 5. On the denominator, we have 4 plus square root of 5 times 4 minus square root of 5. And if we distribute them in, right? If we distribute them in, square root of 7 times 4 will give you 4 square root of 7. Square root of 7 times 5 to give you square root of 35. And on the bottom, 4 times 4 is 16. Square root of 5 times square root of 5 will give you minus 5 on the outside. Because a square root of 5 times square root of 5 to give you square root of 25. And a square root of 25 is basically 5 on the outside. And once you have that, 16 minus 5 to give you 11. So this is your answer, ladies and gentlemen. There's nothing you can simplify. 7 does not contain a perfect square, and 35 does not contain a perfect square. So this is our answer. Let me ask you guys a question here. Question with this particular problem. Well, if you don't have question, let's take a look at another one, right? Let's take a look at this item here. We have a square root. Again, please do not say, square root of 11 plus square root of 2, that will give me square root of 13, and square root of 13 on top, square root of 13 on bottom is equal to 1. No, that's not it, right? In order for you to add, remember the number inside your radical have to be the same. If they are not the same, you cannot combine them together. So looking at this thing here, hopefully you recognize that the denominator, my item, I have a square root of 11 plus square root of 2. In order to get rid of the square root where they have an addition or subtraction, I need to multiply the conjugate. And the conjugate in this case will be square root of 11 minus 2. And if I multiply, if I distribute them in, right, I need to distribute the numerator, square root of 13 times square root of 11, 11 times 13 to give me 143. And 13 times 2 to give me square root of 26. Again, I have, because it's underneath the radical, I can take the two number and multiply them. And on the bottom here, all I need is I take a square root of 11 times square root of 11 to give me 11 on the outside. Square root 2 times square root of 2 to give me 2 on the outside. And again, it's a negative because one positive, one negative. And 11 minus 2 to give me 9. And again, we don't need to FOIL. As I mentioned earlier, whenever you have the conjugate, whenever your conjugate, the goal is we need to find a conjugate. And if you can find a conjugate, the middle term, the square root of 22 and a negative square root of 22, they will eventually cancel out. There is no longer a middle term in this conjugate when you multiply the two numbers together. Okay, so question with this particular problem, ladies and gentlemen, question here. I think this thing here is, I think that is the end of 10.5. Let's take a look at 10.6 and then we see if you guys have any question. We have 10.6 and I think 10.7 left. 10.6, if you don't have a question of divide or rationalize, now we move away from simplification of a radical. Now, what happens if they ask you to solve the radical? And to solve the radical, today we're going to do the easy portion of this item here. To solve the radical is very easy. How easy? The first thing you need to do is your radical have to be isolated on one side. That's the one thing that you need to have is, if you look at this problem here, if you have a radical, your radical have to be isolated. It cannot have a radical plus some other number or subtract some other number. This radical have to be on one side and the constant is on the other side. Now, how do you get rid of the radical? And if you remember, I mentioned this in the beginning of chapter 10, the cancellation of the radical. The cancellation of the radical is the square root. And to get rid of the square root, we need to square them. If we have a cube root, to get rid of the cube root, we have to cube them up, right? Which is a square root and a cube root, well, a square root and a square, they cancel out. The only thing is, if you do it on one side, we have to do it on the other side. So if I square on one side of the equation, I have to square on the other side of the equation. And the square and the square root cancel out, so I have 2x minus 5. And on the other side, 5 squared, meaning 5 times 5. 5 times 5 is 25. So in this case, this is what I need to do. I need to add 5 to both sides, and then I need to divide it by 2. So if I divide by 2, I can see that x is equal to 15. And if you look at this thing here, if you plug it back in, 2 times 15 is 30. 30 take away 5 is 25. Square root of 25 is 5. We got our answer. Okay, so the idea is the same. The idea is the same no matter what you have. No matter what you have, the first thing you ask yourself is, do I have a radical on one side isolated by itself? And if I do, this radical is a square root. In order to get rid of the square root, I need to square them up. And if I square on one side, I need to square on the other side. And if I square on the other side, which is 6 times 6 to give me 36. And the reason why I square on this side right here, ladies and gentlemen, the reason why I square on this side is the square root and the square, they cancel each other out. That's why I only have the 4x plus 12 naked, right, by itself. No longer we have a square root, because a square and a square root, we're looking for a pair of 2, and we got a pair of 2. And again, that is what we have. And once we have this thing here, hopefully now it's just a smooth sailing. How do I solve for x? I need to subtract the 12, and 36 minus the 12 to give me 24. I divide the 4, x is equal to 6. And again, you can see 4 times 6 is 24. 24 plus 12 is 36. Square root of 36 is equal to 6. We got the correct answer. Okay. And here come, let's take a look at this thing here. And then we do some more problem on outside. So if you look at this thing here, you will see that I mentioned this item here, right? The first thing you need to ask yourself is your radical, this is your radical, is this radical isolated? Is this radical by itself, right? That's what you need to ask yourself. Well, in this particular problem, no, is not, right? Why is not? Because it still have addition of something here. There is an addition of some lingering, some number here. This is your addition. So this is what you need to do, ladies and gentlemen, is before you can square them up, you need to somehow get rid of that phi. How do I get rid of phi? Well, get rid of phi is easy. I need to move the phi to the other side. And if I move the phi to the other side, I need to subtract. So in this case, we have 12 subtract phi. I have a square root of phi x minus 15 equal to 7. So now we're good to go, right? My isolation is worked out. I have a radical equal to some number. So this is what I have. What do I need to do? I need to square them up. If I have a square root, to get rid of the square root, I need to square. And if I square on one side, I need to square on the other side. And if I square on this side, I have x minus 15. I square on the other side, I have 7 times 7 is 49. And to solve for x, I need to add 15 to give me x equal to 64. Okay. So this is the idea which hopefully some of you or many of you say, oh, that's easy enough. Solving is easy, and solving is not that difficult. Your goal is first you need to have an isolation. And once you have the isolation, you just need to ask yourself, do we have a square root or a cube root? If we have a square root, we square them up. If we have a cube root, we raise it to the third power. So question with this particular problem here, ladies and gentlemen. Any question with this particular item that we have? Now, let's take a look at this problem here. So if you don't have question, let's take a look at this item here. Give me one. So if you look at this problem, if I ask you to solve, and let's say D, let's say Q, let's say 2x, 2x 3. Okay, so if we have this item, which is a if you have this item, which is a little bit different than the previous one, because the previous one we have a square. And I want to point out that it doesn't matter what in this radical. We don't care about the item in the radical for the time being. The first thing you need of is this radical here, do they have any addition to another number or subtraction to another number? And hopefully you say, well, no, right? There's no addition to any number. The only thing is my radical is by itself, right? Unless I have something like this. If I have cube root of 2x plus 1 minus 2 equal to 3. As you can see, if there is some addition or subtraction, then they are not by itself. And if it's not by itself, then we need to do some operation before we can get rid of this, right? So we don't care about this for now. Let's forget. What do we need to do? Well, in order for you to do this idea, remember, if cube root, how do we get rid of a cube root? Well, to get rid of the cube root, this is what you need to do, is you need to raise it to the third power, because the cube root and the third power, they will cancel each other out. And if they cancel each other out, this is what I have, is I have the item in the radical equal to, again, what is this cube root tell me to do? Well, it's tell me that 3 times 3 times 3 times 3. And 3 times 3 is 9, times 3 is 27. So that's what we have here is, again, if we have a cube root, like I keep on mentioning, we raise it to the third power. If we have a square root, we raise it to the second power. If we have a 4 root, next time we do the 4 root, or next problem we do 4 root, you will see that doesn't matter what the root. As long as you have the root, that's what the power you raise it to. And if you have this, the root and the power, they cancel each other out. We have this item. And now how do I solve to solve that one? And if I say 1, this is what I have. I have 2x equal to 26. And then I need to divide it by 2 to give me x equal to 13. And that is my answer, right? And if you're in doubt, right? If you're in doubt, take a look at this item. Right? If this is what I have cube root of 2 times, what is my x? My x is 13. And cube root of 2 times 13 plus 1. Does that mean this is what they tell me is, what is 2 times 13? 2 times 13 is 26. What is 26 plus 1? Well, 26 plus 1 is 27. So what is cube 27? Well, cube 27, we're looking for a pair of 3, which is, do you agree that 27 is a perfect cube? So cube root of 27 is 3. Is that equal to 3? Right? This is what they tell me is equal to 3, equal to 3, equal to 3, which we got this. We find that the number for x that we plug it in there and we simplify, then we get 3 here. And that's what we have here. Okay. So let's do a for root in case if you see, if we have this problem and they give you a for root and it doesn't matter. Let's say that I have 5x minus, let's do let's say if we have something like this, right? Let's say if we have a for root 5x minus 4 equal to 2. The question they ask you is, pick me an x, find me a number for x. When I plug it into this problem, I multiply that x to 5, take away, and that will give me 2. And you're like, oh, you lost me after you subtract 4. But again, don't worry, right? Don't worry. This is what you ask yourself is, whatever root they give you, this is what you need to do is you need to raise it to that power. So because they give you the 4 root, to get rid of the 4 root, we need to raise it to the 4 power. Everybody see that? To get rid of this 4 root, we need to raise it to the 4 power. Last time is a cube root, we raise it to the 3rd power, and the previously we have a square root to the power. We have this item, the root and the power, they cancel out, meaning no longer we have this root, we have 5x minus 4. And whatever I do on one side, I did it to the other side. And in this case, if I do this side, I have 2 times 2 times 2 times 2. That's what the 4 power tell me to do. The 4 power tell me that 2 times 2 is 4. 4 times 2 is 8. And 8 times 2, which is 16. Everybody see that 16 is 2 times 2 times 2 times 2, 4 times. It's not that 2 times 4 is 2 times 2 times 2, 4. Now, as you can see, after you raise it to the 4 power, life hopefully is easy now. Because how do I solve for x? Do you agree that to solve for x, all I need to do is add 4 here. Add 4 there, I have 5x equal to 20. And now how do I get rid of the 5? I divide this by 5 to give me x is equal to 4. And if we in doubt, right? If you in doubt, we can check this out. If we plug this thing in, we have 5 times 4. 5 times 4, that's my x, minus 4. What is 5 times 4? 5 times 4 is 20. And what is 20 minus 4? Well, 20 minus 4 is 16. What is a cube root of 16? We did this last time. How did we get 16 here? Is basically we say that 2 times 2 times 2 times 2, there is a pair of 4. And since there's a pair of 4, we bring one of them on outside, and that is what we have. 2 is equal to 2. Question here, ladies and gentlemen, question with any of this problem here that we have. Let's do one more, and let's say if we have a square root. Let's go back to a square root. Let's say 3x plus 7. 3x plus 7. It's a little bit hard for me to. The answer might not be, maybe not, might not be whole number because of the 3s, but it's okay. So let's say if we have this problem, right? Let's say we have this problem, ladies and gentlemen. So if they ask you to solve, meaning we need to look for x. And again, this is the question they ask you is pick me an x, whatever number you come up with, that you plug in here, you multiply that by 3, you add it to 7, you take a square root 3, that will result in become a 2, right? So that's just your function, or that's your item here. So now how do we do this problem? Well, the first thing you need to ask yourself is the radical, that's the main thing here, ladies and gentlemen, is this radical by itself? And hopefully you say, no, it's not. And yes, you are correct. Because addition, or in this case, subtraction. And how do you get rid of this subtraction? To get rid of the, to get rid of the subtraction, do you agree that we need to add? And if we add this item here, you can see that this is what we have. We have a square root 3x plus 7 equal to 5. Coincidentally, ladies and gentlemen, coincidentally, it's worked out to be a whole number. So looking at this thing here, what do to do? Well, do you see that, hey, my square root is by itself, my radical is by itself. And if a radical is by itself, everybody see that this is all we need to do is, because it's a square root, because my radical is a square root, because there's no number is assumed to be a square. So if it's a square root, I need to raise it to the second power. And if I raise it to the second power, everybody see that the power, they cancel out. So this is what I have is 3x plus 7 equal to, what is 5 times 5? 5 times 5 is 25. And now, hopefully you say, Mr. Tran, I can't solve it now. I got this. How? Because that we need to minus to both sides. And if we minus 7 to both sides, we have 3x equal to 18. And like I say, I'm not this good. It's just I'm lucky. Coincidentally, I make it on the fly, and the answer is a whole number. Okay. So again, this is what we have is 27 minus 7 to give you 18. Divide that by 3. So this thing here, if you look at this item here, if you plug 6 in here, if you plug 6 into x, 3 times 6 is 18. 18 plus 7 is 25. Square root of 25 is 5. 5 minus 3, that will give you 2. And that's what we have. Okay. So again, looking at this item here, question on where to start or how to start, how I got my answer to become 6 as in x. Now, before I let you guys go, and we will do more of this next time, but before I let you guys go, you will encounter this problem, and I want to show you this item here. If you encounter this problem, and there's a one thing that you will see is, if you see this problem, you know, after this one here, you don't ladies and gentlemen. So if you were to encounter this problem, let me show you that you probably say, my radical is by itself. I need to square them up, right? I need to square this item here. So a square and a square root, they cancel out. And if I cancel out, I have x minus 9 equal to 49, because -7 times -7 is, -7 times -7 is positive 49. And what do I do from here? Hey, way to go. This is what we have, is x equal to 40. But the problem comes, and this is the major problem, ladies and gentlemen. If you plug into your original item as 9, and this thing will give me -7. Is this true? Well, let's take a look at this thing here. This is what you're looking for, right? You're looking for x, and we got it. We got x, and x we say is equal to 40. We plug in 40. So 40 minus 9, do you agree that 40 minus 9 to give you 31? And you say, wait a minute here. Square root of 31. 31 is a prime number. I can see that a square root of 31 is not that number there, right? A square root of 31 is not that number there. So we're in trouble, because we find x, but when we plug it back in, we cannot find an answer, right? Because that's not, square root of 37 is 30, square root of 31 is some number, is 5 point, I think 5.4 something, because again, square root of 25 is 5, square root of 30 is 6. One is between 5 and 6, so probably 5.6 something, right? So it's not equal to 7, right? So we have a problem. And go back to our original problem. Our original problem is this. Our original problem is this. Now, let me ask you guys this question here. And this is the most important thing that you will see. Let me ask you guys this question. Is there any way that I can plug in the x, and then I take a square root of whatever if I take a square root, will I ever take a square root of something and it will give me a negative number? Remember, right? If I give you this question here, remember, if I give you, if you remember in chapter 10.1, no solution, right? There is no way we can take a square root of negative number, because a negative number, for now, we just say that is impossible. So as you can see, as long as you have a radical is a negative number, we say it's impossible. There is no way, there is no chance that you can take a square root of something and it's give you a negative number. Okay, so from here on out, ladies and gentlemen, if you recognize that this problem, and this is where I'm heading, if you have something like this, a square root of 3x plus 13 equal to a negative 10, you don't need to do anything and just say no solution. Because there is no way you can plug in the number in here and then take a square root and that give you a negative number. Okay, there is no way. So if you see a square root, doesn't matter what the square root is. The square root can be square root of 5x minus 17 equal to negative 2. As long as equal to a negative number, we say no solution. It's impossible for you to find me a number that you take a square root and give you a negative. So if you have a radical equal to a negative number, you don't need German. Let's stop here for today. We will do a few